Hello students, welcome to Engineering Helpline, a channel for all engineering students. Today in this video of circuit and system, we will learn how to synthesize a ramp signal and solve various problems. Hello students, welcome to class of network analysis and synthesis. Today in signal synthesis, we will learn more about how to synthesize a ramp signal. This is a ramp signal. We will represent this ramp signal as Fr of t. This is K is the slope of this ramp signal. We all know that slope is represented with tangent theta. We can write Fr of t is equal to 0 for t less than equal to 0, and its value is Kt for t greater than equal to 0. For this part it is Kt, and before this it is 0, where K is the slope of this signal. If the value of K is 1, then this signal is called unit ramp function, and it is represented with R of t. Here this R of t is 0 for t less than 0, and its value is t for t greater than equal to 0. Because value of K is 1, so it will become only t. RT is unit ramp, and Fr of t is any function, any ramp function. And if the signal is shifted, means if it is a shifted ramp, if it is not starting from the origin, it is starting from any other point. As shown in this figure number 15, it is starting from A point. If a ramp function will start from A point, then it is a shifted ramp, and we will write it as Fr of t minus A. Its value is 0 for t less than 0, and is Kt minus A for t greater than equal to 0. Again, K is the slope. This is a shifted ramp. If the value of this slope is 1, then it is called shifted unit ramp, and it is written as Rt minus 1, which is 0 for t less than 0, and is t minus A for t greater than equal to 0, as shown in figure number 16. Rt minus A having a slope of 1, a ramp function starting from point A, not from origin. So now you can remember this is the relationship between a ramp function. R of t is a ramp function, and U of t is a unit step function. R of t is t times unit step, means R of t is TUT, and if it is a shifted ramp, let us it is shifted by A, as is shown in this figure, then it is Rt minus A is equal to, in place of t, you will write t minus A. So it will become Rt minus A is equal to t minus A, U of t minus A. And if a function will start from this side, let it is starting from this minus 5, let it be. So we will write Rt plus 5, then it will be plus 5, t plus 5, U of t minus 5. And if a function is starting from this, it is 5, then this is the equation. Rt minus 5 is t minus 5, U of t minus 5. This is for this, and for this it will be, in place of minus, it will be plus. If I have to write down the expression for this waveform, which is starting minus 5, then it will be Rt plus 5, t plus 5, U of t plus 5. Clear? Now let us see some problems based on these ramp signals. Now let us synthesize figure 17. This is a figure number 17. A function name a of t, a ramp function like this, straight line. This is k, it is 0, it is 1. So to write down this, the expression for this waveform, let us learn a formula. This is the very important formula which you can keep in mind while writing the expression for any ramp function. If you remember this, it is very important. Then easily you can write down the expression for any ramp function. I will call this formula as GS formula. GS. This formula. This ramp function can easily be, you can write it very easily. First of all, you have to write down the slope. Slope you all know is represented with m, which is equal to y2 minus y1 divided by x2 minus x1. This is the slope. First step is to write down the slope. Then you will write t minus passing point from this line, where this line intersects on the x-axis. You will write here, you can see that this line is intersecting at the x-axis at 0. If it is like this, let it be 1, then we will write t minus 1. Then you will write down the expression of a gate function. You all know that the expression for a gate function is u of t minus, suppose this is a gate function. Already I have explained, I will explain once again. This is a gate function starting from 1 and ending at 2. So you will write down u of t minus 1 minus u of t minus 2 for this gate function. So now let us write down the expression for this given problem based on this formula. You all keep this formula in your mind, it's very important. So now let us write down the expression for this. For this expression, for this waveform, the slope is y2 minus y1, k minus 0 upon 1 minus 0. So it will be k. This is the slope for figure number 17. Then t minus passing point, it is passing from 0. So t minus 0. U of t minus this point is starting point, t minus 0 minus u of t minus ending point, it is 1. So the expression will be kt u of t minus u of t minus 1. This is the expression for this waveform. Now next question is figure number 18. This number, if you will see this figure 18 and 17, I am showing you once again. This 17 figure is little bit shifted. Well, shift this, I'll get this figure. In 17, figure number 17 is like this, starting from 0, and figure number 18 is starting from 1, this one. So again we can write down the expression for this. You will write based on the GS formula as already I have explained. A of t is, first of all you will write down the slope. For this slope is k, this line, for this line, what is the slope? y2 minus y1, k minus 0 upon 2 minus 1, it will be k. T minus this line is intersecting the x-axis at 1. So I'll write down k minus into t minus 1. Then a gate function u of t minus 1 minus u of t minus 2. Any signal is when multiplied with a gate function, then outside the gate the function becomes 0, and within the gate the function remain as it is. This is the property of the gate function. So keeping that property into mind, we applied a gate so that we can get the expression only up to this. Otherwise this ramp will go up to this line. So if we will simplify this, you will get k t minus 1 u of t minus 1 u of t minus 2. As figure number 18 is the shifted version of figure number 17, so we can obtain the expression of figure number 18 from the expression of figure number 17 by just putting t is equal to t minus 1. You can also verify from this. This is the expression for figure number 17. Simply if I make t minus 1, so I get k t minus 1. Here you can see k t minus 1 u of t minus 1 minus u of t minus 1 minus 1, so it will be u of t minus 2. So from this expression you can obtain the expression for this by simply putting t is equal to t minus 1 because it is the shifted version. So the next question is, let us synthesize figure number 19. Come to figure number 19. Again, this function figure number 19 has two parts. This is the first part, which is the ramp function. This is the second part, which is a shifted step function. So again, AT consists of two parts, 1 and 2. First of all, I will find the expression for part 1. So applying GS formula, you will get slope. K upon 1 is the slope. Then t minus 0 will give me t. Then I have to apply gate function, which is u of t minus 0 minus 1. This gate starting from this and ending at this. So this is the expression for part 1 up to this point. This bracketed is the expression for part 1. Second is a shifted step function. For a shifted step function, as already we have discussed, expression is, first of all, write down the magnitude, which is k, then u of t minus shifting point. Here it is 1, this is 1. So this is the expression for figure number 19. Okay, are you able to understand? Then next is your, for any doubt you can write down in the chat window and in the comment box. In the next video we will resolve your doubts. This is figure number 20. Now let us synthesize this, or let us write down the expression for this waveform in terms of unit step function or ramp function. This figure, again, figure number 20 has two parts, 1 and 2. First of all, let us write down the expression for 1. Again, what is the slope for this waveform? K minus 0 upon 2a minus a, which is k up a. Simple method, y2 minus y1 upon x2 minus x1. Here is 2a and x1 is a, y2 is k, or y1 is 0. into t minus, this line is intersecting at x-axis at point number A is point A on x-axis, so you will write t minus A. Again you have to write down a gate function starting from A, so you will write u of t minus A till this point u of t minus 2A. So this is the expression for part 1 till this point. Then next is second part, which is a shifted gate function shifting from 2A. So I'll write k u of t minus 2A. This is for second part. Okay. If I'll simplify it, it will come simply k upon A t minus A u of t minus A minus k upon A t minus 2A u of t minus 2A. This is the synthesize of figure number 20. Now next question is, if you will see, this is again the shifted version of the previous waveform. Simply by shifting the previous this expression in the expression of this waveform. This has two parts. So next is in this expression, if you will put t minus A, you will get the expression for figure number 20. The next problem is this one. The difference between figure number 20 and 21 is that in figure number 20 this was the waveform, this was the waveform, means it was open at this side, now it is closed. Means in the previous problem part 2 was a shifted step function, but here part 2 is a gate function. So you have to keep this in your mind, only this is the difference. So A of t is again consisting of two parts, 1 and 2. Slow one is 2 upon 1 and intersecting at t, so 2t, u of t minus 1. This part, for this part it is a gate function, as already I have explained. For a gate function, let us see, this is a gate function. Let me erase the suppose this is for a gate function, this is a gate function. One, 2, k. So the expression for this gate function is k bracket start करेंगे u of t minus 1 minus u of t minus 2. This is the way to write down the expression for a gate function. Magnitude, this is the magnitude of the gate function. Then u of t minus starting point, then u of t minus ending point. It should be 2, sorry. Similarly, in this figure, the second part is a gate function, so I'll write 2 u of t minus 1 minus u of t minus 3. So this will give me the expression for the second part. You can see it easily, you can see that this is the expression for figure number 21. So on solving you will get 2t u of t minus 2t u of t minus 1 plus 2 u of t minus 1 minus 2 u of t minus 3. If I'll simplify it, I'll get 2t u of t minus 2t minus 1 u of t minus 1 minus 2 u of t minus 3. So this is TUT, as already I have told you, TUT is a ramp function RT. So it is a ramp function with a magnitude of 2. So I can write it like this, 2RT. This is a ramp function shifted with 1. So I can write minus 2 or t minus 1 minus, this is a step function having magnitude 2 shifted step. So I'll write 2 u of t minus 3. So this way we can write the expression of any waveform in terms of step and ramp. This is called synthesize. So today we have learned about how to synthesize a ramp function, means how to write down the expression. More such problems we will discuss in the next class, and for any doubt you can give your valuable comments. Always we will definitely resolve those problems in the next video. Thank you.